Sometimes you're in a situation where you're just not sure how your calculator will handle scientific notation. That could be getting a new calculator for the class. That could be having to borrow a calculator on an exam because you forgot yours. Well, today we're going to talk about a method where you can handle the decimal portion and the powers of 10 portion of your scientific notation separately when doing calculations. This lets you work through scientific notation without having to do it correctly on your calculator. So I'm going to talk about the rules first, and then we'll do some examples. To begin, I'm reminding you that the decimal portion is this part of the number that has a decimal, a point, and then the rest of the decimal places following. The power of 10 is the number that is the power of 10 that follows the decimal portion. The first set of rules is for addition and subtraction. The first thing you want to do is convert all your numbers into the same power of 10. Make sure you keep an eye on your sig figs when you do that. You can then add or subtract the decimal portions while paying attention to sig figs, and then you can round to the correct scientific notation format at the end. Now, as a reminder, the correct format will have a single digit to the left of the decimal point. All of those decimal places will reflect the rest of the sig figs in your value, and then you will have the relevant power of 10. Let's contrast that with what you do for multiplication and division. Here, you don't have to convert any numbers first. You just multiply or divide all the decimal portions. Write down the answer to this calculation, and then we're going to handle the powers of 10. When you are multiplying two numbers together, you will add the factors of 10. When you are dividing two numbers, you will subtract the denominator power from the numerator power. At the very end, you'll round to the correct scientific notation format and make sure your sig figs are right. Let's take a look at a few examples. We're going to work through these 4 examples. When we get to our final answers, they will possess the correct number of significant figures and they will be in the proper scientific notation format. Let's start with addition. 3.45 times 10 to the minus 4th plus 8.445 times 10 to the minus 2nd. We're going to convert our 10 to the minus 4th term into 10 to the minus 2nd first. So 3.45 times 10 to the minus 4th. We need to move that decimal place over 2 decimal places so that we get 0.0345 times 10 to the minus 2. Now we can set up our addition. 8.445 times 10 to the minus 2 plus 0.0345 times 10 to the minus 2. First, we're going to add our decimal portions, and that's going to get us 8.4795 times 10 to the minus 2. Now we need to take care of our weak link. Our weak link is the 8.445. It only has 3 decimal places, so we need to round our answer to those 3 decimal places. We've got a 9, and our final digit that we're rounding is a 5. This falls under our special rule. When we have 5 as our final digit and we're rounding, we need to round to the nearest even number. So our final answer here will be 8.480 times 10 to the minus 2. Let's take a look at a subtraction example. 4.255 times 10 to the 3rd minus 1.2900 times 10 to the 2nd. Now remember, we're going to convert all of our numbers into the largest power of 10. 1.2900 times 10 to the 2nd. We need to move that decimal place to the left 1 spot, giving us 0.12900 times 10 to the 3rd. We are not going to drop those 2 zeros. They're significant. We need to keep them. Now we can put everything together. 4.255 times 10 to the 3rd minus 0.12900 times 10 to the 3rd we're going to get 4.12600 times 10 to the third. Now to round to our weak link, that means we need to round to the 3 decimal places. So our final answer is 4.126 times 10 to the third. Now that we've looked at addition and subtraction, let's check out examples for multiplication and division. We'll begin with 6.629 times 10 to the minus 34th times 4.33 times 10 to the 8th. We don't need to do any rounding here. All we need to do is rewrite this so that we handle the decimal portions and the powers of 10 separately. So we're going to multiply the decimal portions of our values. We're going to put in parentheses 6.629 times 4.33, and then that's going to end up times 10. Now in our parentheses here, we're going to deal with our powers of 10. When we are multiplying, remember we add the powers of 10 together. Negative 34 plus 8. Now we can just crunch what's in our parentheses separately. For the decimal portion, we're going to need to round to 3 significant figures because our weak link has 3 sig figs. So that's going to give us 28.7 times 10 to the minus 34 plus 8, so that's minus 26. This is the number we're looking for, but now we need to convert it to the correct scientific notation, which means that we're going to move the decimal place to the left 1 spot. Our final answer becomes 2.87 times 10 to the negative 25th. Our final example is 2.50 times 10 to the minus 25th divided by 3.15 times 10 to the negative 7th. And again, no need to round. We just need to write our decimal portion and our power of 10 portion separately. So let's begin with the decimals. 2.50 divided by 3.15 times 10. Now in more parentheses, when we divide, we subtract the denominator from the numerator. So that's minus 25 minus a negative 7. Let's crunch our decimal portion. We have 3 sig figs in each of our inputs, so our final answer will have 3 sig figs. That'll give us 0.794 times 10 to the, now looking at our minus 25 minus a negative 7, subtracting a negative number is the same as adding that number. So it's going to be negative 25 plus 7. So the next step is 0.794 times 10 to the negative 18. This is the correct number, but we need to express it correctly in scientific notation, which means that we're going to move the decimal place to the right 1 spot, giving us a final answer of 7.94 times 10 to the minus 19th. So there you go. This is how you can handle scientific notation, even if you're using an unfamiliar calculator. I'll see you guys in class.